And welcome back. Today I'm showing you how to turn down a steel shaft in order to get just the right size down to 1/10 of a thousandth of an inch in order to heat a bearing onto said shaft. So the other end is not straight at all. So we'll go ahead and cut a part of it off to get it mostly straight. Then we can face it on the lathe, and its speed is good. Bring the blade down, get a little closer. Well, I'll speed it up so you can actually see that on camera. There you go. Okay, right there. We'll kick it back to just above 1. Stop. And I got a little disc. One for the scrap gun. Alright, next we'll polish it up on the shaft, on the lathe. Alright, so now I have it chucked up in the 3-jaw, and this was a piece of a cooling tower shaft, so it lived outside on the roof, and we installed a new shaft. So this old one, I took a piece of it, the rest of it's in scrap, and to show you how to heat up a bearing onto a shaft, pull from the scrap bin to make these little videos. So the OD is very, very rusty, so I had to run some emery down it. And you can see this is kind of a big piece diameter-wise for this 3-jaw chuck. It wouldn't even fit into the hole in the center of the chuck. So it's up against the face of the chuck. So what I'm doing here is what I figured out is I'm turning down the OD of this, but because it was running out so much, I actually, for the 311 bearing, the 6311 bearing, I should say, that I'm going to be heating onto the shaft, that I need the shaft to be, what was my size? I believe it's 2 166 thousandths of an inch. And this cooling tower shaft was 2 3/16 or 2 187 thousandths of an inch. So I really only had 21 thousandths to turn down to get to the size I needed. But because of how much this piece is running out in the chuck, I'm going to find out here shortly when I put my 2 to 3 mics onto this piece after I machine it down a little bit. It's actually machined it down a little bit too far. I thought I was taking very, very light cuts, but that's why you always need to double check, triple check your measurements, because if this was, for a job or a piece of material that was on the material rack, it would become scrap if you messed it up. But thankfully it was already scrap, and I'm just using it to make these videos. So it actually ended up working out because I was able to think on my feet and literally, and machine it down so that it was running true at that point, or just machine it down enough so I could take the piece out, flip it around, and grab it by that now round part so it wouldn't run out as much on the other side. So that way I could machine the other side down and it wouldn't run out nowhere near close to 20 thousandths. On the lathe, and that way I could actually machine down from 2.187 down, only having to machine down a little bit, down to 2.166, like I said. So of course, with any piece you have on the lathe, I faced it first, which means I ran the turning tool across the front of the material to face it so that it is flat on that side, and then I went ahead and started machining down the OD, the outside diameter, about the thickness of the 6311 bearing that I will be heating on, and that will be a separate video coming very soon after this one, so look out for that. And what I did not picture here, though, is when you machine down an OD to heat a bearing on, you actually, towards the end of the section you machine down, which is going to be the furthest away from you if you're looking at it, this piece that I'm machining on video, the furthest section away that gets machined down, you actually want to put a little recess into the shaft with a radius tool, but of course I don't have one. My coworker has one, but I'm machining these little pieces just for these videos before work starts, so I have to get to work early and do all this. And I don't know, I don't want to ruffle through his toolbox, trying to find something that's not mine, you know what I'm saying? And then here because my turning tool, I actually had to end up switching my one side, the cutting edge of my turning tool actually chipped off a bit. So I actually that's why I had to sandpaper / use emery paper to clean up the finish on the shaft there, because my turning tool got a little chipped off. So you will see me take it out, the cutting tip, I'll take it out, and then I'll actually switch it to one of the two remaining good sides. Then we'll go ahead and take care of that. So you can see here, I'm taking the piece out, flipping it around, and because I faced it, it's now going to sit flat against the face of the chuck. Now I could have machined it down to a thinner OD size, so that would actually fit in the hole of the chuck. But for this purpose, just to make this how-to video, that was not necessary. Plus, now that one side that I faced is flat, the chuck is flat, and I turned it down enough to get it round. It's flat against the chuck, and it's round, being grabbed by the 3 jaws, so that is good enough. And here's a little, I guess, eyeball view of what I'm viewing when I'm, with my safety glasses on, of course, when I'm machining any piece on the lathe, because I have the phone set up on the tailstock pointing towards the lathe, because I need to find a better setup for the videos to point to get you guys a better view of what I'm doing. But for right now, this is what we got going on. And there I'm just putting a little cutting fluid on the center drill, and then I'm actually going to bring you guys closer in, and I'm going to put a center drilled hole in the center, and that's going to come in handy for the next video when I heat the bearing on, and then I will also show you how to pull a bearing off of a shaft. Because when you heat a bearing up, the inside diameter actually heats up so that you can put it on to a steel shaft, and once it cools down, it actually shrinks down and grabs onto the shaft, and you cannot pull that sucker off by hand, no way. So you either have to try to knock it off with like a brass bar and a hammer, or just the hammer directly if you don't need to reuse the bearing. But you can also use a puller, which when I heat the bearing on, I will also show you later in the next video how I pull it off. And you do want to have a center in the shaft for that purpose, but more on that next video. So now I am very carefully turning down the OD of my other side of this scrap piece of shaft, because I don't want to mess this side up. I don't want to go down below that 2.166 sizing. And there's actually, I'll show you a picture right here of the bearing tolerance chart, because I could actually go 2 166 thousandths of an inch, or I could go 2 166.5 thousandths of an inch. In other words, 2.1665 per the bearing chart, because like I said, I am going to be heating on a 6311 bearing. So you see that in the chart there. And then I also take the file and I run it along the edge of the shaft, so that there's a little bit of a chamfer, so it's easier to start the bearing once I heat it on the shaft. Because if you still have a burr on the edge of the shaft, it'll actually stick up just a hair, and it will prevent you from sliding a bearing on the shaft. It'll get stuck on that burr. And if you even get the bearing partially stuck on the shaft and then it shrinks back down and cools off and grabs it, you either have to knock it off or just try to go for it and knock it on with a pipe that matches the ID of the bearing and then a hammer whaling on that pipe, and could work out, it could not. So that's why you always want to deburr the end of your shaft. So there you can see me checking in with the mics, and right there I'm actually 2.1, just a little over 2.1665. So it's a little slightly under 2.166, but for this purpose it'll still work. It'll be fine just for the purpose of the video. But if I was making a shaft, like let's say a pump shaft for bearings to go on, I would want to be right in the money, in the tolerance, because these bearings have a tight tolerance and you want to adhere to that if you're doing, if you're actually machining shafts for jobs and for customers and for buildings, because you want these things to last as long as possible. Okay, thanks for watching.